Hello students, from today onwards we are going to start the real numbers first chapter. Hope you have seen all the previous videos. If you haven't seen yet, please go through that first, then this chapter will make some sense to you. Here we will start with 1.1 introduction. Line by line of NCERT we are going to see. We will not skip any single line of NCERT and we will try to do full analysis of this book, and each and every question, each and every topic and hidden concept we will go through it. So first is introduction of the real numbers. From here we will start. In class 9 you begin your exploration of the world of real numbers and encountered irrational numbers. So here they are assuming that you know about irrational number already. Okay, so if you don't remember, we will just do quick review and then we will come back here. In class 9 we have seen in the number system chapter irrational number. So we are going to do recap of it. In that you have studied an irrational number cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So irrational number you can't write in the form of p by q. You can write rational number in the form of p by q but not irrational number. Examples which was given in your book in class 9: root 2, root 3, root 15, pi, these all are irrational number. Root 16 is not irrational number, means perfect square numbers are not irrational because root 16 can be written as 4. Here one more example is given, which was given in your NCERT book as well: 0.101101110, like this. So you are seeing here none of the number is repeating. It is not called repeating. Here 101 is coming, then you see again 101 came, after that 110 came, then 11110 came. So you can't predict the next number what will come. So this type of number is called irrational number, where it is non-terminating, non-repeating. It is non-repeating as well, and with that it is not terminating as well. Terminating means breaking, so it is not terminating. Then infinitely many irrational number exist. You can write many irrational number. Infinite irrational numbers are there, that also was there in class 9. So irrational numbers plus rational number makes the real number. Okay, hope you have understood what you have studied in class 9. So we continue our discussion on real numbers in this chapter. We begin with very important properties of positive integers in section 1.2. In section 1.2 we are going to start, they are saying, for of positive integers properties. Here it is 1.1, after this 1.2 will be there. If you don't have NCERT, please arrange it fast, because every day when I will upload the video it will be easy for you to understand. If you have PDF form also it will be helpful, or you can keep one notebook with you, keep on making notes with what I am explaining, namely the Euclid division algorithm. These two things, Euclid's division algorithm and fundamental theorem of arithmetic, these two are the main topic in this chapter, and on these two only this entire chapter is based. If these two are clear to you, you will easily get 6 marks from real numbers chapter. Okay, so first one is Euclid division algorithm. In this, as the name suggests, has to do with divisibility of integers. Okay, here we are going to divide two integers. Stated simply, it says any positive integer a, it can be any positive integer a, can be divided by another positive integer b. Okay, we are dividing a with b in such a way that it leaves the remainder r, that is smaller than b. Whatever r will come, whatever remainder will come, that has to be lesser than b. For example, if you are dividing 5 with 5, so what remainder will come here? Quotient will come 1, remainder will come 0. So this 0 is lesser than 5, right? If you will divide 9 with 5, then what remainder will come? 4. And if you will divide 10 with 5, then remainder will be 0. We will quickly see Euclid division algorithm. Here I said you a is equal to bq plus r, where r has to be greater than or equal to 0 and lesser than b. Here a is dividend, b is divisor, q is quotient, r is remainder. Okay, so example we are taking here 47 divided by 5. So if you are dividing 47 by 5, what will come? 9 times it will come 45, so 2 will be the remainder here. So this one we can write in the form of Euclid division algorithm form, which is a is equal to bq plus r. So 9 5 is 45 plus 2, which will give you 47. So check whether 2 is lesser than b or not and greater than or equal to 0 or not. Yes, it is satisfying this given equation. So what is the difference between equation and expression, students? Equation contains equal sign. Because it contains equal sign, a is equal to bq plus r, so we can say it as equation. Okay, and r is lesser than b and greater than or equal to 0. This also you have to, this condition also you have to mention while solving the Euclid division algorithm sums. Okay, in bracket you should write these things while solving the sums. So this also we will discuss how to present your answer during exam time. Next is, many of you probably recognize this as the usual long division process. You will think that it is usual long division process only, but this result is quite easy to state and understand. It has many applications related to the divisibility properties of integers. So after this they are saying we touch upon a few of them. We are going to touch upon few of them of its application and use it mainly to compute the SCF of two positive integers, and we are going to use it to find the SCF of two positive integers. So we will also quickly see what are the application of Euclid division algorithm, then we will come back. So student, we will quickly see the application of the Euclid division algorithm. Here it is written Euclidean, it is same only, Euclid division algorithm. Find SCF of two positive integers, mainly we use for it, but there are many other applications also. It is not for your exam purpose, it is just to show you that other application also exist, like check divisibility, express numbers in structured form, prove properties of numbers, foundation for modular arithmetic, advanced algorithm in computer science. So these are the some of the use of Euclid division algorithm in which we are going to see find SCF of two positive integers in this chapter. Now second important topic of this chapter is the fundamental theorem of arithmetic. On the other hand, has to do something with multiplication of positive integers. This one, fundamental theorem of arithmetic, it is all about multiplication of positive integers. You already know that every composite number can be expressed as a product of primes in a unique way. They have written you already know. That means you should have knowledge here of the composite number can be expressed as a product of prime numbers in a unique way. And student, what I am trying to do here, if you don't have knowledge also, previous knowledge, so then also you can able to understand it. I will just quickly review it and then come back to this again. We will quickly see, student, fundamental theorem of arithmetic, what actually you should know before starting this chapter. The multiplication of positive integers can be uniquely expressed as the product of prime numbers, right? You can write 60 in the form of product of prime numbers like 2 into 2 into 3 into 5. Always you have to remember the factorization into prime number is unique, ignoring the order. Means you can write like 5 into 3 into 2 into 2 also. So that time you didn't change the prime numbers, you just change the order of it. So we have to ignore the order, so then every number can be written in unique way. Understood? Like for example 84, 2 into 2 into 3 into 7. For 210 it will be 2 into 3 into 5 into 7. So now composite numbers can be expressed as a product of prime numbers in a unique way. This factorization is unique, right? Order of primes does not matter. And the writing of composite number in the unique prime numbers product is only called the fundamental theorem of arithmetic. So hope it is clear to you now. And again, while it is a result that is easy to state and understand, it has some very deep and significant application like the Euclid division algorithm. Okay, here also they are saying the same thing. Again what they are using, because that one also was very simple but having lots of application. This also have lots of application in the field of mathematics. We use the fundamental theorem of arithmetic for two main application. First, we use to prove the irrationality of many of the numbers you studied in class 9. Hope in this again they are using that you have studied in class 9. So something they pre-assume that you have studied, you have knowledge of some of the rational number which we have discussed already, so such as root 2, root 3, root 5. Second, we apply this theorem to explore when exactly the decimal expansion of a rational number, say p by q, where q should not equal to 0. This is also important thing. where q should not equal to 0. If q will become 0, then what will happen? If p by 0 will come, then it will become non-defined number. Okay, we can't define it. And q should not equal to 0, then we can say where this number will terminate, and when it is non terminating repeating number. Non terminating repeating number means what? 0.33333333. It is non terminating and repeating. So we do so by looking at the prime factorization of the denominator q of p by q. Here what we do, suppose 1 by 3 is there, so just you will prime factorize this denominator. So if you will do prime factorization, 3 is a prime number, so there will be no prime factorization further. So 3, so but just by seeing this number you can say whether it will terminate or not terminate. We will do more discussion on it in the future videos. You will see that the prime factorization of q will completely reveal the nature of the decimal expansion of p by q. You will see the prime factorization of q. What is q? Denominator will completely reveal. Here they are forcing this word completely reveal. Okay, these things you have to, these small things you have to keep in mind in NCERT. It will completely reveal, not partially, completely say the nature of decimal expansion. Means it will say whether the number will terminate or not terminate. Just by seeing the q, prime factorization of q, you can able to say that. One quick recap, student, till now what we have covered. We have started real numbers from introduction, and then we have seen what we have studied in class 9. From there we tried to recap it, and then we have seen the two important topics which we are going to cover in this chapter: Euclid division algorithm and the fundamental theorem of arithmetic. Then we have seen Euclid division algorithm formula, which is a is equal to bq plus r, where r has to be lesser than b and equal to or greater than 0. Then we have seen fundamental theorem of arithmetic, and we have also seen in Euclid division algorithm that there are many application, but in this chapter we are going to use it for mainly finding the SCF of two positive integers. For the fundamental theorem of arithmetic, we have seen that fundamental theorem of arithmetic also have many application, but we use it for two reason: to prove the irrationality of the numbers which you have studied in class 9, like many irrational number. So to prove it whether that number is how those numbers are irrational. And second thing is, when the number is in the form of p by q, where q is not equal to 0, so how that number will behave in decimal, whether it will be terminating or non terminating repeating number. So we have covered this many things in today's video. In next video we are going to continue this chapter. Hope you have enjoyed this video. So let me know in the comment section, students, what extra we can do in this so it will be more useful for you people. Write me in the comment section. We will continue in the next video. Thank you.